Assalamualaikum warahmatullahi wabarakatuh. To all my fellow panels, Dr. Muhammad Fairuz bin Ramli and Dr. Firdaus bin Muhammad. My name is Muhammad Ammar bin Azizan. Today, I will be presenting my final year project proposal under the title of Study on Variation of Lubrication Oil, Effect the Wear and Durability of Engine. I am under Supervisor PROF MADYA IRTS Dr. ROSLI bin Abdullah. Project summary. The major goal of this research is to study variation of lubrication oil effect the wear and durability of engine by investigating the tribological performance of a hydrogenated DLC coating in the presence of a group 3 mineral base oil, 4 other fully formulated oils and a fully synthetic group 4 PAO under boundary lubrication circumstances. A pin-on-plate tribotester been used in this experiment by applying high-speed steel grade plates coating of hydrogenated DLC slide against cast iron pins. Besides, scanning electron and optical microscopes been applied to analyze wear scar and to examine the coating's durability. Introduction. Lubrication is science or process of minimizing and reducing friction exists between the rubbing surfaces of two solid bodies in relative motion by applying lubricant. Since fuel economy improvement demanding was increasing, automotive firms must create something different to be applied in two primary sectors, lubrication technology and material. There are two additives that involved in this study. The first one is zinc dialkyl dithiophosphat, ZDDP, which is anti-wear additive, and MODTC, molybdenum dithiocarbamates, which is friction modifiers. All of the lubricant will be tested on DLC coating, diamond-like carbon, that were commonly been used especially at automotive engine sliding parts and other uses. This coating have various advantages, including their nature friendly due to very low friction, high corrosion resistant, and good in wear resistant. Literature review. The first literature review did a research about anti-wear additives and friction modifiers effect on coating of hydrogenated DLC tribological performance. Lubricating oils involved is zinc dithiophosphat and organomolybdenum. The tribological test been carried out under boundary lubrication in pin-on-plate tribometer. Results proven that ZDDP produced zinc phosphate consists of ultra-thin anti-wear tribofilm that provide excellent wear durability protection to DLC coating. However, this additive's anti-wear performance been compromised as it was used with friction modifiers. Second literature review did a study about tribofilm's evolution under the lubrication conditions occurred in trans engine valve. In this experiment, block on ring tribometer that employs steel components was used. Lubrication oil used is mineral-based oil consists of zinc dialkyl dithiophosphat with full detergent dispersant antioxidant package and a same blend but with molybdenum dithiocarbamate. The result shows that the reduction of friction is actually the consequence of tribofilm shear strength changes and not nanoscale topography of tribofilm surface. Third literature review also had presented his study about graphite effect on friction and wear properties of molybdenum dithiocarbamate MODTC. It is found that graphite powder added with dispersant to oil consists of MODTC considerably seen improved friction and wear performance, while graphite powder appeared to be absorbed on rubbing surfaces but without film that consists of MOS2, therefore decrease friction and wear by preventing direct contact between the rubbing surfaces. Problem statement. The problem is to decrease dependence on traditional sulfur and phosphorus consists of lubricant additives that harmful and dangerous that affect environment like zinc dialkyl dithiophosphat. So is the new friction modifiers is effective compared to ZDDP. So the objective of this study is to compare coating durability and wear effect when used all of the lubricant oil. Second one is to compare friction and wear coefficient of all the lubrication oil involved. And the last one is to study and acknowledge the most suitable selection lubricant oil for engine. Scope and limitation of project. There are 6 types of lubricant that involve Group 3 mineral base oil, fully synthetic Group 4 PAO, fully formulated oil without friction modifier, fully formulated oil with friction modifier, fully formulated oil without friction modifier and zinc dialkyl diphosphate, fully formulated oil with friction modifier but without zinc dialkyl diphosphate. And the parameters involve friction analysis, coating durability and wear, and surface analysis. Methodology. Preparation of lubricant. Group 3 mineral base oil, completely synthetic Group 4 PAO and 4 distinct fully formulated oils were used in this experiment. The suggested provider will provide all of the oils and the key additive components for each oil were listed in table below. Pin-on-plate test. Tests were conducted using a moving pin-on-plate turbometer under boundary lubrication conditions. Steel plate with DLC coating been used in this experiment. First, the samples been cleaned inside ultrasonic bath with acetone for 15 minutes before test start. Then, the contact point of the plate and pin was submerged under a static volume of all the lubricant at 100 degrees Celsius and the average linear speed was 20 mm per second. Load of 390 Newton used that gave an initial Hertzian contact pressure of 0.7 GPa, simulating a similar pressure range to a typical contact gasoline engine. Friction force data was collected every second corresponding to 2 cycles. Duration of the test was 6 hours and each type of the test was done 3 times to determine friction performance and the average of repeatability had been calculated. Surface analysis. Coefficients of wear been calculated by measuring the diameter of wear on pin. Light microscope was used to measure the wear scarce diameter of pin, and then the volume of lost segments of sphere was measured. The wear coefficients were calculated by using Arcad wear equation. K equal to V over Fs. F is the normal load, S is the sliding distance, V is the wear volume, and K is the dimensional wear coefficient. Expected results. Friction result. From friction traces respect to time from previous investigation, it can be observed that all fully formulated oil followed same trend over time. The other oils exhibited a clear decrease in friction over time. Figure below show the expected mean of steady state friction coefficient values for the last 1 hour compared to the ZDDP free version of this oil, which is oil 4. The existence of MOFM combination with ZDDP in the oil 2 formulation resulted in a slightly friction reduction as we compare oil 1 and oil 3. When ZDDP added to fully formulated oil, friction increases. Besides, when base oil group 3 and PAO with no additive were used, there was a decrease in friction, and it was found that the additive-free PAO recorded the least steady-state coefficient of friction among all the oils. Wear coefficients. After the expected wear coefficients for each lubricant been calculated, the expected result show that PAO and oil 4 provide the least wear coefficient. Total wear was slightly lesser in fully formulated oil without ZDDP and friction modifier, which is oil 3, compared to fully formulated oil without friction modifier, which is oil 1, while base oil group 3 was higher compared to in fully formulated oil with friction modifier, which is oil 2. Surface analysis. If the DLC coating was lubricated in PAO, severe delamination was observed in many locations, whereas mild delamination of the DLC coated plate was observed when lubricated in Group 3 base oil. In contrast, no delamination found in completely formulated oils. Rather, the coatings wear was dominated by gradually polishing wear. The term delamination used in this study refers to coating removal from substrate. That's all from me. Thank you.